Relational versus Non-Relational Databases by IST110 Group 3. Data is the bedrock of our economy and quickly becoming the foundation of our society. Businesses, governments, organizations, and people need to be able to gather, organize, and understand these data and its implications. There are two primary types of databases used today: relational and non-relational or NoSQL databases. Why not just use text files, word processors, or spreadsheets? Most spreadsheets and text files can't handle more than multiple megabytes of data. As organizations need greater capacity, databases become the best option. Most text files and spreadsheets do not allow multiple people to access and update the files at the same time. Databases allow multiple users to access, update, and request information at the same time. To ensure the accuracy of data being entered, databases are all set up with rules or schema to ensure that data is entered properly. Security features for these types of files are usually inadequate for an organization's most important data. Most modern databases have embedded security features that are routinely updated. Multiple entries of the same data in a file can lead to data conflict. Databases alleviate the problem of data redundancy. Databases are best served for important data. Word processors and spreadsheets do occasionally crash, and users may lose data. Nearly all modern databases have backups to ensure data is not lost. What are relational databases used for? We all encounter relational databases with modern banking, medical, and payment systems, just to name a few. All databases use database management systems to create and manage their databases. Companies like Oracle, MySQL, Microsoft, Sybase, and IBM all offer commercial database management systems. Relational databases are first organized into tables, which are formalized repeating lists of data. Each table has columns and rows. A column defines a piece of data and imposes rules on the data entered into that column. Each row in a table represents a set of related data, and every row in the table has the same structure. Relational databases use structured query language, or SQL, which is a high-level coding language, to add, delete, and update data. Relational databases also use what's known as schema on write, in which certain rules for data is validated by the database. But relational databases have limitations. First, they are difficult to scale up. Database servers are very expensive, and an organization will need to hire more database administrators to manage the database. Second, they are difficult to scale out, which means they generally won't scale beyond the many terabyte or petabyte size. Third, they require database administrators who specialize in tuning and managing the rules and processes for the database. Finally, they are meant to host only structured data, and in a world with a huge expanse of unstructured and semi-structured data, like videos, pictures, tweets, and Facebook feeds, this can be problematic. Non-relational, or NoSQL databases, were developed to alleviate those problems. They were first developed by Google, Yahoo, and Facebook to solve web-scale problems like indexing the entire internet, predicting subscriber behavior, and creating targeted advertising for their platforms. There are over 150 non-relational database management systems operating today in both open source and the commercial sector. There are 4 types of non-relational databases: key value, column, document, and graph. Each has its own unique capability and is tailored towards specific types of unstructured or semi-structured data or different problem sets. These databases can handle massive amounts of data which can be collected in real time. And these databases are very easy to scale. The reason these databases have become so popular is due to their ability to handle the 4 V's. The volume of data has grown exponentially since Web 2.0 and the Internet of Things have come onto the scene. The variety of data is also ever evolving, and relational database management systems cannot manage this new type of data. The velocity of data coming into databases is too fast for relational databases to handle. The veracity or need to extract value from this data has never been greater. Finally, the cloud has made the development and use of these databases and data storage cheap and easy. But these databases also have limitations. Because these databases are schema on read versus schema on write, there is little validation of the data once it's entered. In other words, the data integrity is low. For this reason, banks, medical institutions, and the like still use relational databases to store data. Unlike relational databases, once data is entered into a non-relational databases, it cannot be edited. Non-relational databases also tend to lag behind relational databases in query response time. So what does the future hold for databases? We can anticipate that the 4 V's will continue to drive the non-relational database model, and the need for data integrity will keep relational databases around for a long time. But as Guy Harrison, author of Next Generation Databases, discussed, we can expect to see the best aspects of both relational and non-relational databases merge into a single system. However, as technology continues to evolve, we may not know what we need until that need is at our doorstep.